So my name's Simon Parfy. I'm from a company called Soil Biolab. We specialise in a very particular type of soil testing where we look at soil life. And in recent years we have become a lot more involved in projects and trials relating to understanding more about tree health, and that's why we're in Sherwood Forest today looking at the major oak. The purpose of today's visit is to do some groundwork, quite literally, so we're digging holes in the soil to understand a little bit more about what's going on beneath the kind of pasture that you see around the roots of the tree. There's various things that we'll be doing today. The first is digging a trial pit, which allows us to understand what's going on in the different horizons of the soil, where there may or may not be roots. And that's really important because understanding the presence or absence of roots helps us understand a little bit more about the health of the tree. And obviously this is a really important tree that we want to make sure lives for many years to come. And so we'll also be doing some soil testing as well. So we've got different locations mapped around the tree where we'll be collecting a bit of soil from the top fraction, the top soil, the aerobic zone, which is where most of the soil activity occurs, the soil microorganisms which break down organic matter and help make foods available to the tree. And we'll also be sampling from a little bit lower down as well, up to 60 to 80 centimetres depth, which is the subsoil. And there's a lot of misunderstanding or misperceptions perhaps about where trees are or where the presence of their roots are. And actually, historically, this tree has had some ground penetrating radar which has helped inform where we dig these particular pits so that we can understand exactly where to target to make sure that we are over those rooting areas. Topsoil sample, which I mentioned about kind of containing most of the life in the soil, that's one of the bits that we specialise in, looking at bacteria and fungi in soil. So we'll take samples of soil back to our laboratory, we'll make a series of extractions from them where we'll isolate and then begin to count and identify the presence of bacteria or fungi, other organisms like protozoa and nematodes as well. And when we put all of that together, that helps give us a picture about what's happening in the soil. Is it a healthy soil? Are things in balance or not? And we'll also do some work with the fine roots from the tree. We'll look for a particular type of fungi called mycorrhizal fungi, which bonds with the tree roots, it colonises it, it covers the surfaces of the tree roots and forms almost like an extension of the tree's rooting system, helping it get water, helping it collect nutrients as well. And a presence of a good or a strong percentage colonisation on these fine roots is a good indicator of good tree health. Historically, the tree has been very well managed, arguably possibly over-managed, and with trees there is very often a delay in seeing the onset of stresses. They could take some years to potentially manifest, and so some of the stresses which we might see in a tree like the major oak might relate to work that was carried out years ago or lack of intervention years ago. So what we're kind of hoping to achieve from this work today is initially create a baseline, so get some really comprehensive, solid information on soil that as we go forwards we can refer back to this point in time and understand in terms of soil health what the state of the soil was at this point in time, because it's obviously such an important tree for a whole host of reasons. The concern is really about preserving it and keeping it in the best condition possible for many people to enjoy for years to come. So the trial pit, which we spoke about, is one of the most important parts of the process because it gives us a better understanding about what is going on through the different layers in the soil, which means that we can target the soil sampling we're doing specifically to address some of those observations that we make. And one of the observations that we made in the trial pit is a distinct lack of potentially oak tree roots. We found lots of roots, we think, from another tree, another species of tree, but we're unsure that the fine roots are oak roots at this stage, but these are very much contained within a particular layer of the soil. There's not a lot above it, and there is a compacted layer above, and there's not a lot underneath it, and there are again further compaction layers. So what we're kind of seeing is a very thin layer of soil where there are tree roots, but they're not necessarily from the tree behind me. And that's really interesting because actually it makes us question about where we need to look for tree roots to complete our assessments in the laboratory. Where do we collect those roots from here today on the site? Maybe we need to alter our sampling locations accordingly, but maybe we also need to alter our expectations of where within the soil horizons we need to collect those roots as well. So yeah, really interesting exercise and really important for the process.